Okay, so our next slide is about data representations. Okay, so what is data representations? Okay, so before we explore more about data representation, there is one thing that you need to know, that is, computers actually are amazing devices that enables people to do a wide variety of things with the computer. Okay, so people can use the computer to view information, okay, listen to music, play games, and many more. Okay, so in order for computers to work, okay, they must represent the information in some way. Okay, so all data actually is stored within a computer and transferred from or to a computer, is transmitted as a series of electrical signals that are either on or off. Okay, so to process the data, whether it be text, images, or sounds, okay, the computer must convert the information into binary form. Okay, so the binary number system is a base 2 number system. This means it only has two numbers, that is a 0 and 1. So all information in a computer, okay, such example words, pictures, movies, sound, is stored and transmitted as sequences of bits or binary digits. Okay, so in a simple word, okay, we can say that data representation refers to the form in which data is stored, processed, and transmitted in our devices. So the process of converting information, okay, as I said earlier, such as text, numbers, photos, or music, into digital data that can be manipulated by electronic devices is called digitization. Okay, so you need to memorize, okay, that a group of 8 bits, okay, is called a byte, and it usually abbreviated as an uppercase B. Okay, all right, so a bit, okay, is a 0 or 1 used in a digital representations of data. So terminology related to bits and bytes, okay, is extensively used to describe the storage capacity and network access speed. Okay, so the computers, okay, all right, so this slides, okay, actually illustrate, okay, the character B that has been decoded into binary and how they display back to the users. Okay, so computers actually convert text and other data into binary by using an assigned ASCII value. Okay, once the ASCII value is known, that value can be converted into binary. In the following, in this example, okay, we take the letter B and show how it's converted into binary that the computer understands. Okay, so let's take, okay, the character B example and break down the process. Okay, once the letter B in uppercase, okay, is typed on the keyboard, a signal to the computer as input. Okay, so the computer knows the ASCII standard value for B is 066, which can be converted by the computer into a binary value, that is a 01000010. Okay, so after the capital B is converted into binary, the computer can store and process the data as ones and zeros. Okay, so when the computer needs to convert the binary data back to human readable text, okay, so it's the reverse, sorry, for the previously shown process. Okay, so for example, a computer may convert the binary 01000010 into the decimal value 066, which is known as the letter B using the ASCII standard conversions. Okay, so hence you see the letter B output to your computer's monitor. Okay, so and then here, okay, another example of data representations of word byte. Okay, so B, they have their own ASCII code. Y, they have their own ASCII code. That is how the computer process the data.